Hey, all right, Joel. What's on the agenda for today?
Cool. Yeah, so I kind of
Oh God.
doc80 specification, like yeah, what that is and why we need it and how it works. Other than that, there's just like a few loose things that I want to sync up on the core protocol. And actually, since Sergey is here, we could also sync on um, the a thing we thought about with basically refactoring ceramic core to be more modular. So you can like, instead of like passing configurations for like different pinning services and anchoring services, you kind of send in the modules. Um, but we can dive into that later. First, I wanted to just present the doc80 encoding. Um, so I think most of you may have seen this already, but basically, let's see if I can find, I have too many windows. This. Cool. So the doc ID is basically an identifier for a document in Ceramic. Just kind of have always refer to a Ceramic document by saying ceramic : / and then an IPFS CID of the first record in a document. That's been fine for now, but there are some problems with that, mainly that we need to always have this kind of prefix before the CID, and if we don't have that, we can't uniquely know that we're talking about a document, ceramic document. So it's kind of like use the same identifier as an IPFS object, which is not always optimal. So instead, we're creating this doc ID encoding. And basically what this is like a unique identifier for the document without any like need of any prefix or something like that.
Joel, can you zoom in?
Oh yeah.
Just on the content. Yeah. A little more. Maybe it's just my bad eyes or my small screen.
Is this better?
Yeah, that's good.
Cool. All right. So basically what this does, it takes the data that's in a CID and prepends that with a multi-codec for document IDs and a kind of namespace. And so this is just like two more pieces of additional data. And that can be encoded using multibase. So multibase is like a way of like referring to like any data in any specific base encoding. So that can be like base 16 is hex, or base 32, or base 58, or whatever. And just like a way to like interpret the data. So that's also from the IPFS team of multi-formats. And I'm not going to dive too much into that yet. But basically, it's fairly straightforward. So we just like take this multi-base prefix. I mean, if you're familiar with CIDs, content IDs in IPFS, this is going to be very straightforward. If not, this might be a little bit very specific. But anyway, so multi-base prefix is just like one character usually that describes which base this string is encoded in. The multi-codec for doc80, and this is basically like an variant that describe that as unique as a unique multi-codec. And yeah, there's this multi-codec table defined in the multi-formats. Let me show that actually. So yeah, sorry, my internet is very slow today. And we integer, the one I've chosen, and we'll see if we get it, is CE for ceramic. But yeah, basically multi-codec is this way of like having a unique thing, a unique codec representation for a bunch of different things. So if you look at the table, here we can see there's, for example, a multi-codec for CAD. There's a multi-codec 6. There are multi-codecs for a bunch of different hashes encodings. So if something is the CBOR or just raw data, interesting, you can like encode torrents as content IDs. You can encode Ethereum blocks and a bunch of stuff. Yeah, basically, we're reducing one of the codecs for to be like this prefix that uniquely identifies the document. And we have a namespace, and namespace is fairly undefined right now, but it's basically just like a varant, and a varant is just like an unsigned integer that can have variable length. So I think up until 80, the integer is just like 1 byte, and then it becomes 2 bytes, and then grows, and it has like one byte that's always like signifying like how long the how large the size is for that integer. And after that, after a namespace, we just put the CAD, the bytes from the CAD of the Genesis record. And this is taken like directly from the CAD SPIC. So for CAD1, the full document ID would be encoded as multibase, multi-codec for doc-ID, a namespace, and then multi-codec for CAD-V1. So it might be like CBOR or PB, which is like the older IPFS coding. There's a bunch of other IPLD coding, multi-hash for the content. And actually, like a multi-hash is made up of like an encoding for which hash function it is, how long the hash is, and yeah. So this is like a lot of stuff in here, I guess. But yeah, so that's this is inspired by the CADs. We're just kind of like extending CADs, and here you can see kind of a similar thing where they have like this is basically what people to this thing put into here. Yeah, this will allow us to like, instead of having document ID, we can just like put this multi-base string and just like interpret the first variant to get the multi-codec, and then set multi-codec doc-ID. We know how to interpret the rest of that string. All right, so a little bit about the namespace. And the namespace is right now, as I said, a varant. And initially we'll use 1 to be like the live network ceramic when that's ready. And until then, we'll use 2 for the test. The namespace might be used for different things in the future. So either it's used for more networks, or there might be some reason to like have, if we're like sharding all documents, we might want to like be able to put a document in a specific shard, or maybe a specific region or something like that. And in that case, we could use this namespace to do that. Yeah, and we might need to like define a table for like what these different namespaces are in the future, but kind of punting on that for now. And yeah, this will be a breaking change from the current version of Ceramic testnet, but I think it's worth it. Okay. Any questions about this new document ID encoding?
Yeah, another point to add that's cool is like we've been having conversations with like the textile team about how they could do things like use ceramic documents as an external like way to create access controllers for textile threads, and they're working on a new version of a thread ID spec, which basically is like a path, and it's something, and then slash access controller, then slash thread ID. And so if you in one way to do that access controller is it's an IPFS hash, a CID. So basically, like if you add a new writer to a thread, it actually generates a new thread, and it kind of like forks the old one. But if you were to use ceramic documents as access controllers, you could maintain that thread ID even if you update the writers, right? Because ceramic doc IDs never change, unlike IPFS CIDs. So, but the problem was that if you use ceramic / doc ID, then it doesn't fit nicely into other things like paths, because then you have a bunch of slashes and it kind of throws everything off. So this is also a way just to like make it just a string that eliminates all the prefix characters, which is
Yeah.
good because then you can drop it in things.
Yeah, and the nice thing about that is like you can encode this with the same kind of
Joel
look
just
at the first variant, and if
Joel,
the first variant is, oh, I was saying, is it better now?
a little, but try to talk slowly. Seems like it overloads quickly.
Okay, let me just stop sharing and stop my video. The nice thing about this is that if you have the string that's just like a multi-base string, and then you can just look at the first variant, and if that variant represents a CID, then you know, okay, I can parse this as a CID. If that represents like a document ID, okay, then you know that it's a document ID. So you can get this nice way of like interpreting the data, which is great. And that especially like in systems like with textile where they want to encode that in like the same way, it's like perfect. Cool. Any other questions on doc IDs specifically?
No, I don't think so. The question is like, how will we go about, or can go about like adding new namespaces? Can anyone do that? Just put random variants there, or like what's that process like for, what if someone just put 3 in there? What would happen?
I mean, I think it would break. Like, I don't think we should like dynamically, like the software can't probably not like dynamically accept things, but we could probably like specify a process for like claiming, like similar to the multi-codec, just claiming different namespaces. But I don't see like an immediate need for that right now. But if something comes out that like where that's really needed, then we should build out a process for that.
Yeah, I agree, because like I imagine we immediately, would want to dissuade people from just using random or adding a bunch of random namespaces, because then in some ways it's like documents might not be respected across them, right?
Yeah, I mean, I imagine this is your node to do that. That seems like a low level setting.
Yeah, do we need to like, is it a configuration we need to add to the node where you say like this node is going to like only respect documents on this in this namespace? Like how, so this is a spec and this is how you can create documents, but what do you actually have to do with the node?
Yeah, I mean, I imagine we have this node operates on the testnet, or this node operates on the live network. So I imagine the setting is not like which namespace do you want to use. It's more like, okay, so which network are you on? Does that make sense?
Yeah, so do you imagine like people, so at some point in the future, we would extend it to say like, you know, there's, um, can you guys still hear me?
Yep.
Okay, cool. Yeah, I just saw the videos go. Is there, do you imagine that if people added new namespaces on, like they would be on either LiveNet or TestNet, so you'd be like, right now we just have one for LiveNet or mainnet, but you could have, if three is like LiveNet, some sub shard.
I imagine that we might have, there could be a feature where some of the new namespaces represent like a shard within the live, and some new namespaces. And I think we should probably allow for both in case we want to like have a new testnet or something like that.
Yeah. Yeah, I'm just like wondering what the future implications of that are for like document interoperability and composability. If you like, could I just specify my node can handle all LiveNet shards? Like how rigid would those shards actually be?
Yeah. Yeah, good question. Like I imagine the shards more have to do with like the tip tracking of documents using like an like incentivized part of Ceramic. So like when there's like an incentive system that keeps track of documents, the like shard ID is just, or namespace is just like which shard on the incentivized network is it on. But I don't know if that's the right approach yet, or if we can do that in some other way. But that's how I imagine that working. That's just like how the incentivized system interprets it, but not necessarily which documents you can sync.
Yep, it's not like a hard shard. It's just a way for you to just like logically make sense of subsets of things for, which might be valuable when incentivizing tracking.
Yeah, exactly. Or it might actually be like different pub sub rooms that you have to connect to like multiple. But I think there's a lot of details there and nuances between like different solutions. That's why I kind of wanted to keep the namespace fairly undefined now, so that we can use it in the way we need in the future.
Yep.
Uh,
Any thoughts from anyone? Oh yes, Sergey, I see you just posted.
Yeah. So name-specific broadcasting. So it's worth mentioning using different topics for different namespaces. That's kind of what we wanted to do first, with like one being like the live network and two being the test network. So they would be in like different pub subgroups. So yeah, exactly. They would be like, the namespaces would be different pub sub topics.
Yeah, because as we were saying, it's like a document network like, or a data network like this or IPFS. It's all on the same, it's like still on IPFS. It's just like, how do we make sense of different subsets of that? Unlike Ethereum,
Yep.
testnet, which are actually different peer networks, is like the same peer network.
Cool. All right, that's that. I have some just small updates that so one thing that we're currently working on is taking the JS DID library that we've created and integrating that into Ceramic. So that will kind of be a consolidation of a bunch of work we have been doing for some time. So that's like a combination of a standard that we're proposing for the Ethereum JSON RPC. It's called DID. It's like some utils for DIDs to sign Jose objects. So like Ethereum can natively like create signed documents using like an IETF standard for encoding signed objects, and also decrypt JWTs, and that's the same thing for encryption, and kind of doing that around DID. So JSDID is kind of like we interact with the JSON RPC interface. And on the IPFS side, we are part of specifying a standard called, or like a specification for something called DAG Jose, specifying how it should be stored as like an IPFS DAG object. And basically what that means is you can like sign some data, and you can still follow the links through the signed object, because like usually Jose uploaded so that the payload is like base64 URL encoded, which is like you can't really interpret the data in there. So this would allow us to like follow links through signed data. And we kind of want to integrate these standards so that we can kind of nicely have the interaction between like a wallet and data that lives on this peer-to-peer web.
Hey Joel, you're breaking up a bit.
Yeah. I'm just going to try to talk a little bit slower. Also, we've been working on right now an update to our identity wallet that's is used right now within 3box, but it's also used within Ceramic, and basically allowing this identity wallet to create a DID on the Ceramic network and then associate different authentication methods with the. But the main thing that I wanted to sing or like give an update on is, so we're kind of, up until now, we kind of just stored the public keys as hex encoded if it's like a SIC 256K1 key, or if it's like an X25519 key used for encryption that's been stored as like base64. So it's just like random encodings for those things. And what I'm doing right now for actually storing that data in the 380 Ceramic document is taking those keys and encoding them using prefix and like a multi-codec identifier. So there is like a multi-codec identifier for SICP 256K1 keys. There is one for X25519. So we're just going to use those codecs and then encode that data in 58, I believe. Yeah, because I think that's the base. The nice thing about like this way of encoding the public keys is that there is another DID method called DID-key, which is like the simplest DID method possible, where it's just like, that's the public key of this DID and it's impossible to rotate. yeah, they're using exactly this encoding for the public key. So that's kind of neat. So we kind of have converging way of encoding these public. Yeah, so one thing that needs to change in like the 380 DAD resolver and JS ceramic implementation is that we need to like interpret codec key and convert that into the key that's needed in the format it's needed to be stored in the DAD document. And that's like, I think, also base 58, but without the multi-codec thing. The question, Animal, is that different than multi-base encoding? So when you encode, yeah, so you actually use multi-base. So this multi-codec key encoding basically is like a multi-base. Actually, maybe I can pull it up if I can find it quickly. Give me 1 second. Let's see here. I'm just going to try to find it first. So basically, yes, it's not different from multi-base. It's using multi-base. And it's also using, let's see if this works. Right. Okay. Let's see if I can share this again. I'm just going to stop my video again. Okay, so basically, let's hope this loads. Connection doesn't drop off. So you use multi-base, and then to say like which base you encode the key in. Okay, here. So this is the spec for the key, and basically multi-base encode that you use base 58 BTC, and oops, okay. All right, move this. And then the thing that you're encoding with multi-base is the multi-codec for the public key type. So that's like SECP 256K1 or ED25519 or X25519, or you might encode some like BLS probably as well. And then you just take the raw bytes of the public key. So basically you add first the multi-base, then the multi-codec, then the bytes of the public key. So you cannot use both, if that makes sense.
Got it, thanks. It's DAD method key, right? The link.
Yeah, so this is a DAD method called the key, and it's basically a very simple DAD method, but it doesn't allow you to do like key rotations. So if you like, you can't like rotate keys if your keys get compromised or something.
Got it.
You also can't add multiple keys, right?
Yeah, you can't change anything about the DAD document, so you can't like add more information to your DAD or anything like that. Okay. Anything else I wanted to give an update on? No, I think that's mainly it. Yep. Oh, yeah, I want to talk about also, so Sergey, who's on the call, he contributed like another backend for ping like a log of documents that makes up a ceramic document. And basically what that does is like either you can pin the records of a document in IPFS, That's like what Ceramic does by default. And that's like the local instance of IPFS node that Ceramic has access to. Or now we can also back that stuff back up in Filecoin and pin the data there. So like actually make deals with miners to store that data, which is super cool. But one thing we realized as that was implemented is that we should, if we have like all these different, might implement more on like Arweave or Storj or some different like backup mechanism or like incentivized backup network. Like that makes the Ceramic core implementation super huge and not really like something that's easy to use from a browser, which is like inconvenient. So instead, what we thought that we could do is like actually by default, you kind of only have this really thin pinning that like uses the internal IPFS node modules. That's what there could be like one module for like pinning on an external IPFS service, could be one module for pinning on Coin, one module for like pinning on Arweave or something different. And we can actually do the same thing with the anchoring service that's being used. So right now we have like built like an anchoring service for Ethereum, but if we want to have like an anchoring service for Bitcoin or Filecoin or Polkadot, you could use that in as modules. So I think that's like a refactor of the core implementation that we are likely going to do sometime soon.
Did I ask a question on that topic? The storage service, pinning service, sorry. Like, I just wanted to, like, how are you storing that? What do you call it? The PowerGate. Are you using PowerGate, right?
Mm-hmm.
So they have something called FFS instance. Yeah, so that token. Could you share something more about how this token handled?
Well, may I answer this? Basically, you pass this token information in a configuration, well, in a connection string that is parsed by that PowerGate instance. So it gets that token and uses that to connect to your preferred FFS instance.
Right.
So it's passed there.
So we're not storing this FFS token on Ceramic, right?
No, we're not storing this. It's provided as an configuration option for Ceramic Daemon.
Okay, got it.
So if you want to use PowerGate pinning, first you have to obtain somehow that token,
okay.
and then pass it to Ceramic node.
Got it. Thanks.
Cool. I could not hear the full question. Yeah, I think that's it from all of the updates that I had. Janko, who is the other dev on JS Ceramic, is out this week. Otherwise, I think we have more things to discuss here. Yeah. Anything else, like questions or other things they want to discuss? We can maybe do that. Otherwise, I think we're done for today.
No, I think that's good to me. And when Yanko's back, I'm sure he'll have a lot of stuff to report that he's been working on. What's been Yanko, or what's been on Yanko's plate?
Yeah, so that's basically what I talked about earlier in this call with just implementing the use of JS DAD within Ceramic.
Yeah. Okay. Then we can give everyone 20 minutes back or so if there are no more questions. But also, I forget, I think some of you may have been on the CEA call kickoff, but if you're interested in the identity piece, we have an identity working group on Tuesday. We expect to be fairly well attended, and we'll spend that time breaking up the larger identity working group into smaller sub working groups, and just like reviewing kind of IDX and how it relates to all other related identity efforts going on throughout the world. So that's interesting. That's on Tuesday. You can get it just by, signing up for the CA and being on the calendar. Okay, then no other questions. Everyone gets 20 minutes back. Thanks for joining. See you guys sometime soon on the internet.
Thanks.
See ya.
Cheers.